All right, so we're starting the new topic called it's geometry, and I think it's called geometry and measurement. I've put trigonometry, pretty much doing trig and measurement, like all your volume and all that. So at the start, we're going to talk about things we need to know. So the few things, like if we've got a complementary angle. So you don't get asked as such to define these things. You just sort of need to know to help you problem solve. So you sort of got to know if you've got a right angle. So if they put a thing, you know that these two angles would add up to 90. So if they gave you one of them, you can work out the other. Now, alternate angles. So the thing with these ones, the alternate angles, you need to be able to see these parallel lines. So parallel lines mean they're running alongside each other. So if we have parallel lines and then we have this line intersecting through it, so we mean this one going through there, what they're saying is that alternate angles are equal. So this angle in here is equal to that angle in there. So when do you see this in your work, when you're going to see it, is often later on we'll be doing bearings, and you often have like point, say this is point A, and then you have its north line, and you might have say point B up here and its north line, and so you might be joining them two, and you're doing a question about that. So what we're saying is, if you know, say this angle is I'm going to just say 30 degrees, well then in there is 30 degrees. Okay, so that's what these those parallel lines and alternate angles will come into play. And underneath here with the co-interior, when we've got the co-interior, we've got these parallel lines. We're saying that if we've got that line intersecting, that the angles in here will add up to 180. So what I can say is, if I look over at my example over here, if this is 30, these have to add up to 180. So that one is 150 degrees because they're co-interior. Okay, so I could say that's co-interior. All right, so there's something that you can see there. The one over here, we know that a straight line adds up to 180. So just be able to be aware of that if you have it in a scenario. So say, for example, often, you might have, something standing there, and then they say, you've got an angle up. They might say that, this is 20, this is 90 or something, and so this one's right angle. So that's 70. But I mean, you can just add it up. So that's mainly what you're looking for. The one around the point. So often you forget that if you're going right around a circle, you get 360. So if you were around a point, so once again, they'll probably come up a lot in bearings and things and setting up. So if right around a whole thing would equal 360. So I can see there's a straight line there, so I know that one's 150, and then this one over here is 180 because there's a straight line in there. So it's just things like this. When you have the corresponding angles, so I often like to say it's like when you're in the same pattern. So you can see they've got that intersecting line there, and the angle here, and in the pattern, the one just on top of the parallel line, they're the same. All right. The other one, vertically opposite. So these two angles would equal, and these two angles would equal. So pretty stuff you've done before. Acute means it's less than 90. Obtuse means between 90 and 180. And reflex is bigger than. So it's not like you get asked to define it. It just might be a little piece of the puzzle. So let's have a look at these questions here. So if I look at, this one here, we've got 2x minus 50, and they've got this one here. Now, because they're alternate angles, I know that they are equal to, so they're alternate angles and they equal each other. So I can say 2x minus 50 must equal x plus 10, okay? If you are not good at your algebra, you can always, by this stage, pop that in your calculator and go solve if you like. Otherwise, I can bring the x's on one side and I'm going to bring the 50 on the other. So I get x equals 60 degrees. Okay, so, but solve will get you there. You just need to know that they are equal to each other. So here, down in this last one, bottom one, we've got two unknowns. So we've got the x and we've also got a y. So first of all, I think I'm going to find out these x, because I'm going to do like I just did before, where I say alternate angles equal. So I'm just writing this down. You don't need to write that alternate angles equal. I'm just writing it so you know for your notes. So you've got 2x plus 80 must equal x plus 100. So we're going to solve for x. So you can pop it in your calculator as solve if you like, but I'm just going to quickly solve it algebraically. So I'm going to get x equals 20. So now I know that x equals 20. I actually know that this angle in here must be 120. Okay, now these two angles here, those ones there, they're co-interior. So they're co-interior, so they add up to 180. So I know if they add up to 180, so there's 120 up here, this one must add up to 60. So because y, it's already got 60 there, y must equal 0. Okay, so that one, because we already know, so co-interior. All right, so the other thing we need to look at are properties of triangles as well. So if you have the interior angles of a triangle, so they're all on the inside, they add up to 180, and I think we're pretty all aware of that. Now, the other one they're saying, this B plus A equals D. So they're saying that these two interior ones, which are opposite this exterior, they equal each other. Okay? And so we can learn that fact. Now, the other little facts we need to remember is if we have an isosceles triangle. So isosceles means two sides are the same, and we actually know that these two angles would be down the bottom opposite the two same sides are the same as well. Okay, if you have an equilateral triangle here, equilateral triangle means all the sides are the same. So we'd actually have all the sides that are the same, and the angles are also going to always be 60 degrees, because an equilateral means their angles are all equal, and if the triangle has to add up to 180, an equilateral will always have 60 degrees at all of its angles. So there's just and then a couple of other little fun facts. The exterior angles, so then when you have these, if you extend the lines, so if you extend the lines out like that, those exterior angles add up to 360. All right. You don't see, I don't see them talking a lot about this stuff, and they'll probably always describe it. But a bisector means it cuts it in half, so it's exactly halfway through. So a bisector of angles on an equilateral triangle. So, and you can see if you do that, if you cut your equilateral triangle, you create little right angle triangles in there. All right, so you're gonna always have these notes, so you don't have to worry too much. Like if you need, you might just flick to this page if you're trying to work out stuff. All right, so let's do some questions here. Now we're gonna find out a few. Now we know if we can find out x because we know that all those interior angles, the angles inside, have to add up to 180. So x is going to equal 180 minus 42. So x is going to equal 138 degrees. So have a look there, and that looks pretty good, that it looks like an angle of 138. So it's good ways to check. So we know that x equals 138 degrees. Now with trigonometry and geometry, there's sometimes many ways to get your answer, or the way you see it might not be the way I see it, but there's more than one way to find your answer. So why I'm saying this is that you might see that that's a straight line. So therefore 180 minus x would equal y. So 180 minus 138 equals y. So 42 equals y. Or someone else might see it from that other rule that we said, where we said this angle, this exterior angle, equals these two added together. Okay, so as I said, there's always many ways to find answers in trigonometry. Now with this other one, we've got the 100 up here, and because they're saying x and x down in the angles here, we know that's therefore an equilateral triangle, an isosceles triangle. So I do suggest you put little things like that on your triangles, because you might need that fact later on. Now because it's an equilateral, but it's still a triangle, they've got to add up to 180. So I'd have, if you go 180 minus 100, you're left with 80, and we're going to divide that by 2 so that we know that these are 40 degrees down here. Okay. All right, so I'll just do a quick exam question. So here. So in the triangle ABC, the point D lies on the line AC as shown in the diagram. Okay, so that was just telling you that you have a straight line along here. Like we can consider that a straight line. Okay, and it says the length of BC is equal to the length of BD. So you can see that there. So, as I know, if that is an equilateral triangle, then these two angles must be equal. Okay? So when they start asking which statement is true, when it says the angle BAD, it's always the letter in the middle of it that is the one that you're looking at. So BAD, so what you would be doing is you go BAD. So that's where you're looking at that. So that's where this angle in here is angle BAD. Okay, so I've highlighted them in colors. So the BAD is the blue, and it said it is equal to the ADB, which was the green one. I'm saying that's that green one. Now those two are not equal. But you can already see it as well if you look at the diagram. So we're going to say no, that's not true. The next one, angle ABD, so the green one, is equal to the red one. Well, we know that is not true too, because you can see as well, this is definitely larger. But if it says the sum of the pink one, of the angle, the pink one and the green one. So what they're saying is this angle plus this angle is equal to 180. Well, I would say yes, that's true, because there's a straight line, and this one here in the red is also the same size as the pink one. So we're going to say yes, that is true. So this one ends up being your answer. Okay, so that's the way that's the type of question you got in a year 12 exam. That was, I think, 2019.